I don't have a presentation to start off the session. Um, I can talk about like what I want to accomplish and change in Postgres. Um, but it'll just be me talking and hand waving, and I don't want to do that for too long. Um, basically, um, Postgres has tons of metrics, tons of statistics, which you, in order to access, you have to um, connect to the Postgres database and issue SQL queries. And that makes perfect sense to an SQL programmer, to a DBA, but to a sysadmin that's administering a complex system with many other systems, it would be much easier for them if those metrics were available um, in the same systems that they use to keep track of the metrics from their operating system and their networking stack and their application and so on. And those systems don't provide an SQL interface. They provide like Prometheus metrics or open metrics, which is basically the same thing. And they're kind of a relational model, but kind of flattened down. So it's just sort of more like a data warehouse thing where you just have a bunch of, you have very distinct, you have labels which are like the um, I'm trying to remember fact, and in the data warehousing model you have the key of your data model, and then you've just got one value for each. Um, so it's sort of like a relational model where the columns are very distinctly, these are the labels and these are and this is the one value for each row. And they allow you to query, but only query in certain ways based on. Anyways, I'm getting into the weeds. The point is, the state of the art is that everyone has to run an agent alongside Postgres, which connects to Postgres and runs SQL queries, maps all of those metrics to, or not all of them because we have kind of too many, um, maps all those metrics to like Prometheus metrics, and then gets scraped by Prometheus or M3 or whatever the equivalent, Datadog and so on. Um, and in my experience, that caused a lot of headaches. Um, Instead of just trying to monitor your database, now you also have to monitor this agent because your failure modes, all your failure modes of the database are now duplicated, that you can, your database can look like it's unhealthy either because the database is unhealthy or the agent is unhealthy. Um, and also all those mappings are done by the author of the agent, and they're not a Postgres developer and don't really understand some of the metrics. But also we keep adding metrics to Postgres and they can't keep up. Like they can't make the agent um, always reflect. I mean, they're always behind by some amount, some amount of time, and they also have difficulty. Like if you're running different versions of Postgres and we change the semantics of those metrics in Postgres, it's very hard for the agent to now try and put those metrics into a common, because we change it in ways that make it hard for them to map those metrics to a common data model for across versions. And the other thing is people, those agents, people have to supplement them with, because they don't try and do all the metrics. Everyone has different metrics from the Postgres. So yeah, I guess I have a list of complaints. One is that the agent makes things unreliable. Another is that the mapping is not perfect for various reasons. And another is um, the mapping is incomplete. Like we add metrics that make sense in a relational model that are very hard to map to a flat model without making choices about which data from our model they're you're going to keep and how you're going to represent it, because you have to so different people map them differently, and that means that everyone needs to design their own dashboards and their own alerts, and that means it's very hard to you I think that loses a lot of the benefit of these systems, where in my ideal world you'd spin up a Postgres database and your existing monitor infrastructure would immediately just start picking up the metrics. That there's a service discovery layer that is a whole sort of side discussion, but it would, like, the if there was a standard set of metrics that all Postgres databases
You're talking about more, is it more that you're talking about the production of them? Like, so that like it would be always automatically publishing? Is that more the thing, Greg, as well? I mean, obviously in the understanding of what they are.
So I mean, the heart of what I wanted to do is have Postgres talk native Prometheus or Open Metrics protocol.
Okay.
So that if there was also service discovery working, either because of the way you deploy Postgres or because Postgres actually also interfaced with the service discovery things, Prometheus works on a pull model, so it would, if it knows that the Postgres instance is there, it would then connect and pull those metrics. But that depends on obviously service discovery, but also depends on there being a standard set of metrics that would be a reasonable size data set that also was enough in depth that everyone would be happy. Like, they would meet.
I don't think I've ever met the person. I don't think I've ever met 10 people that agree on the same metrics, though, for a database. Greg, is the problem.
Yeah, that's a big. So
because everyone has a different cut on what they're trying to like look at for a database, right? So
yeah, like, well, what do you mean by that? Because I'm kind of,
because like there's like because part of the problem with like database metrics is there's different levels, right? Like there's the overall database metrics, right? That you have like goofy things like hit ratio, right? Like, is the classic one that we all used to look at like 20 years ago, right? But now you have like per query, per session, per object metrics happening, right? And so, someone will say, well, no, I've got to see what every query is doing, and I've got to see metrics on every one of those queries, either like summarized over time or current instantaneous, right? And so there's a lot of different cuts on it, right? I mean,
I think part of that, like I mean, I was getting at the same issue with per object metrics and per query, and a lot of that comes also from, there's different kinds of users. Like there's users who have one big database and one application, and it's very complex, and they need to pick it apart. And then there's other users who have very simple databases, but they have 1,000 of them.
Right.
And they yeah. And then there's the DBA who isn't so concerned with the queries and the objects, but they're really concerned with the storage or the uptime, and not so much
one part of what I was thinking was like, one of the interesting things that we found is sort of just like trying to put together the OS sort of metrics from like, the Postgres servers along with the Postgres data, which is why I was kind of talking about like, how do you publish data, right? Because then you have different agents that are doing different things, and are you getting the same data at the same frequencies, and all those pieces of fun as well.
But I mean, to some degree, people have the same problem with like OS data. Like, some people are really interested in the file system data for each file system, or maybe even like each user. And then other people are not so interested in like in-depth file system data. They just want to know whether there's been errors and more high-level stuff.
Yeah.
And I think they like there are ways of getting more in-depth data, but there's sort of an accepted set of like, if you're monitoring a system, this is the base level, like this is how you know whether the system is still operating.
Sure.
There is also an interesting point of view on this case, because you said there is always a way to get more in-depth data, which is not actually the case, unfortunately. There were a lot of patches on the hackers that were following the very same pattern, when essentially people were coming saying, we have a corner case, performance corner case, we would like to monitor this, this, and that. And the answer was always that it's just too much overhead for everyone else. So, I mean, this type of stuff, it's not even possible to like even provide this data on somehow more generic, in a more generic way, let's say this way.
Yeah. Yeah, I mean, I do agree, Greg, that I mean, like trying to get to a set of curated sort of metrics of the critical things and having those be published in a way that integrates better with systems is probably a good starting point. It is an interesting thing to say, well, okay, but when you do find a problem, where's the rest of the data, right? And I mean, one of the things that kind of that's different about Postgres, that like coming from, let's say, an Oracle background, is that Postgres doesn't have any repository mechanism for capturing and keeping its performance stats, or an example like vacuum stats, in a way that is consumable over time, right? So it means that if you want them, you kind of have to emit them to another system on some regular basis as well, right? So it is kind of an interesting problem, because I know with like Oracle back in the day, we used to do things like we'd pull basic metrics off the system, but we would never pull like all the metrics, because we were like, well, if we need to do in-depth investigation, we'll go to this, that specific Oracle database. We'll drill in with whatever Oracle tools are, and it's got the history for like the last 21 or 30 days or whatever, right? But Postgres not having that facility means that I think a lot of people do what we do, which is we export a lot of stuff, out to another system, so that you have more data, whether it's our performance insight stuff, which is basically weights and SQL, or metrics to our CloudWatch stuff, for longer term retention, because there is no real facility to go back and grab that. So yeah, it's an interesting problem.
I mean, I'd like to. I tried to do a nice dashboard in Grafana for a previous employer, and presented it, and then people ask me, okay, so how do I get that same dashboard? I was like, well, first you have to deploy these queries in your agent, and you have to like the labels. The dashboard assumes that you have your data structured in a certain way with certain labels, and I think where things like Grafana are headed is that you should be able to just turn on a dashboard, and you should have your data in a standard form, like standard set of labels, so that it just works. But I think there's, I mean, the extra labels that we had there is a separate problem. But even the basic queries that, like the basic data that we were using for those dashboards, aren't in what the agent exports by default.
Right.
And everyone writes those queries slightly differently, because they're trying to focus on different subsets of the data. So like, yeah, like something like PG stats query is always going to be a lot of data, but it should be like a thing you turn on, not a thing that you then decide like to write a query to pick just certain queries and an aggregate. I'm thinking out loud.
Yeah. But that's why I was thinking about publishing, like getting to like having almost a backend publisher for metrics that you could configure that would spit them out in like an open metrics, like in some standard format, right? So as you know, if you could just do that and you say like, hey, when you install Postgres, if you basically flip this flag on, we're going to publish, and then you can have some configuration around metrics, and then like a metric system can just pick that up and run with it, right? And you don't have to change the agents. You don't have to have an agent that specifically knows about Postgres. It just can pick up open metrics and go, right. And then you don't have another. You don't have some process that has to because one of the things about picking up metrics is always the security around the permissions, and you got this other thing connecting to the database all the time, connecting, disconnecting. To me, it would seem like just having an agent that spits this stuff out into something that can be picked up might be a useful thing.
The security issues, don't actually go away entirely. In fact, they become a bit of a problem if we're integrating it in Postgres. But that's an important point. Another point, though, is as you said, connecting to the database all the time. A lot of our metrics are only visible inside the database in question, and so if you have multiple databases in your cluster, the agent either has to have connections to all of them, or you have to scrape them as if they're separate instances, and that's a impedance mismatch with the way these monitoring tools work. That's a real pain. So that is one of the things I was hoping having native support would make go away, that it would just give you all the data for all your databases in a single scrape.
Right.
That's not necessarily obviously going to be easy, but it would definitely make it easier for the monitoring side. The other thing,
I'm
go ahead.
monitoring quite a few databases for one customer using.
You're really quiet, Julian. You're gonna have to do something.
Okay, hold on. Same procedures.
Julian and his mic
I
issues.
just tried to scream a little louder. Does it work half well now? Yeah, so I find it really difficult. So all those metrics end up in a Postgres database. I think with timescale DB for some time related queries and so on, but it is quite the challenge to design dashboards that are useful sort of at a very high level to get an overview of are all my databases, all my clusters behaving very well. And then in another, so then you see something sparks out there, something jumps out at you, and you want to drill down, and well, then I usually have to go to a different dashboard, or sometimes if I want to have this very top level overview, like I want to see out of in one cluster there are almost 30 databases. So I want to have an aggregate overview. Which of these 30 databases is responsible for most of the traffic? So then I have to write ad hoc queries and have to know very specifically where all that data is in my metrics. And so I think that is a very hard challenge, but I'm not doing this for such a long time that I would have a good idea on how to solve that. That's just my 2 cents here.
Yeah, a lot of the dashboards are for a single database, and it's hard to think of ways of presenting the data for hundreds or thousands of databases that are useful, like where it's hard to come up with a set of data and a set of a way of presenting the data that is useful both for the people that have many databases and just want a high level view, and also a single database that want more in-depth view, and then for the application programmer that wants to dive down, like dig even deeper into individual objects or queries.
Perhaps sufficient to decide we'll just have the basic set of metrics that would be sufficient to understand key performance metrics for a single database in a single cluster, for example, and not have this. For what's also kind of difficult is the mapping of highly available replicas to their primaries. Usually it's just another database instance, so you first have to go to some dashboard to figure out which of those is the primary, and so on. If all of these dashboards are sort of built to understand which one is currently the primary and which one is the replica, then that blows the complexity of the queries right out of the water and makes performance suffer. And also primary replica assignments change over time. So which point do you choose in the time gradient?
It's worse than that if you have different databases in your replication scheme that might not even agree on who's the primary. So a previous employer, actually, they were using Sloaney at the time, and Sloaney can output the topology from each node because it's you can connect to each node and ask, what do you think the topology is? I think that's what it was doing. I'm not sure. Outputted a dot diagram, and then in JavaScript used a JavaScript library that actually rendered the topology with like a dot diagram with circles and arrows. So you actually got, there were 3 nodes, so you got 3 diagrams, and if they looked the same, then you knew that they were consistent. And when you were doing a failover, you could see one of them change, and then the other ones change to match. And it was, and I've tried to reproduce the same thing with Prometheus and well, not in was it in Grafana? I think it was just a Prometheus console page, which but I actually never got it working. I think the data from PG replication stats and PG replication slots is very hard to represent, to actually construct
that requires useful, understandable application names that sort of at least match your host names or something like
that. So the slot names were arbitrary things, but they didn't match they were hard to match up with the data from the other node saying that the replication stats. So like it was really hard to figure out. You could tell from an individual node what it was replicating from, but you couldn't tell from that node that it was like it. I wanted to, for example, detect if a node thought it was primary and if a node didn't think it was primary and another node thought it was supposed to be connecting to it. And it was really hard to write alerts or a dashboard that tried to condense that into a single representation. And when I finally did, it also didn't work very well because the scrapes were not happening at the same time. And yeah, I don't remember all the problems we had, but it was really so there's multiple. I mean, some problems are the data just isn't the data for replication anyways isn't really designed for monitoring the whole replication set as in a single monitoring application. But the other is it's meant for monitoring a single database. Is this database operating properly? But it's hard to tell if the other nodes are. It's hard to tell if the other nodes are consistent with the node that it thinks it's replicating from it. But the other thing is the data was not too hard for a human to interpret. It was just that it was full of things like node, like replication slot name and node. I don't remember if there's a node name or a node. There were strings, which is really hard to make use of in the monitoring system that's expecting numeric, like floating point metrics that it can monitor. Some of the tables we have richer data in them than is easy to represent in monitoring software. And the replication data was one example of that. I'm trying to think of another example because replication is a really complicated one.
One thing I think is relevant that I don't know that we really appreciate as much as maybe we should is that while, yeah, there's some base set of metrics that make sense to monitor for everything, I find that some of the best monitoring that can be done is when you get to actually define what you want to have monitored, like how many rows are in this table, or how many rows in this table have a certain state, right? Like how many active rows are there versus like the vast swath of stuff that's inactive or dormant or whatever. And that kind of leads me down an argument that if we go and do this in Postgres, and I like the general idea of putting an agent in Postgres or making Postgres speak these protocols, like as a somebody who deals with kind of data design, I would want to be able to define my own, right? Like, how do we do that, right? That's where I think it becomes a lot more interesting to start defining these things inside of Postgres. Like, I want to define a particular metric that gets exported out to my monitoring system that is unique to my environment because it's tracking something that is relevant really just to my environment with the stuff that I'm doing in this system. Like, that's where I think it gets really interesting, and that's something that I think would be the greatest advantage to having something built into Postgres, is that then, like, I as a DBA type or whatever data designer or monitoring person can go like write my own query that then gets saved by Postgres, and it just pulls this data and it automatically updates my dashboards, so I don't have to go hack around with this agent's configurations.
But isn't so my first instinct is the opposite. I mean, I agree that those queries are very valuable. But I feel like part of what I'm trying to do is separate those two kinds of queries, like the application monitoring that's different for every user, from the Postgres system monitoring that you can, if that is most valuable if you can rely on it always being there and being the same. And
I agree with that being valuable, but I'm just saying, like, that is, I mean, that's almost like table scraps, right? We should just have that. And
yeah.
What I'm saying is that we should also have, all of the appetizers and whatnot that really, allow you to get a better sense of how your system is operating. So I guess what I'm trying to say is that in the event that we do this, that we build something in Postgres, we want to make sure it's extensible.
But in order to run SQL queries, like, you need a transaction. You need access to the database. You need to be in a specific database. You need, like, it brings up all these same problems that, and I guess part of what I was hoping to solve by building it into Postgres was you might not need a normal SQL access. You might not need, it might be a separate permission instead of a normal Postgres user. and it can access, it can get, if it can get, in an ideal world, and I'm not sure I'm going to be able to achieve this, like if it can get all the data it needs from the stats system, from the shared memory, without actually accessing, without actually having a transaction, for example, then like your monitoring doesn't break because your so like right now with the agent, your monitoring breaks if you run out of connections. Your monitoring breaks if you reach transaction wraparound and you can't start a transaction, which actually I think is less of a problem in modern versions. But for many versions, it was like you lost all your data, like your monitoring, when transaction wraparound hit, because it couldn't even connect and get a transaction. Your monitoring breaks if you write a query that like hits a lock. Like, so if you do something like select count from table, and that table has something else that's doing an exclusive lock on it, your monitoring breaks. So like I was in my head anyways, like part of the thinking is that the monitoring should be more low level and not be doing SQL, like transactional SQL to get this stuff. It should be pulling it straight out of shared memory so that it's reliable and not and reliably consistent, like not so flexible as SQL. Like the flexibility is in a way like what I think is undermining these metrics, that you can't rely on them being the same in every system. I I do agree that end-to-end monitoring, like those kinds of queries, I think what makes them valuable is that they are an end-to-end philosophy, that you're monitoring like whether the system is actually doing what you want it to be doing, not just whether the underlying pieces are working. But I think like in order what I find at previous jobs is that people are monitoring that stuff, but then they're surprised when something breaks and they go and look at it and say, oh, well, there were like deadlocks happening all the time and we have nothing monitoring for errors in the error, like the rate, the error rate, which is like a table scrap. I'd say table stakes, not table scraps, but that's like table stakes for monitoring, that you should be monitoring error rates and rollbacks and disk IO errors and things like that. And you should be getting that like just for turning on the monitoring before you even start writing queries. So I feel like it would be better to have those kinds of end-to-end application monitoring in a separate sorry, in a separate tool from the base like Postgres metrics. So you'd have the flexibility to write any SQL you want, and you wouldn't, and then you would need to have a connection, you would need to have a user, you'd run the risk of hitting locks or SQL issues like slow running queries or something, but you wouldn't be at risk of undermining the like the low level stats that were exported directly. That's, I don't know if that's, if I didn't really mean this session to be me like arguing, but like I just wanted to get that idea.
I mean, I think there's some interesting points here, right? About, I think like some of the discussion of like, you know, should there be an agent? Maybe not. Should there be this like ability just to grab metrics directly without SQL? That's kind of cool. I think there's the permission issues, like the per database thing, which is kind of goofy and does make it a lot more complex for people to have observability of their entire instance, right? At a go. Those are all interesting things.
Yet also, in general, comprehension of all those metrics from the even cluster perspective, it's not there for all those replicas and everything, for all the statuses.
Mm-hmm. Did you finish your? I'm sorry.
Yeah, I'm thinking now, but yeah, I finished my sentence. Sorry for that. And actually, I was thinking that I also like the point about extensibility, and I wonder if it's actually a good example or not, because like one part of this observability breakthrough you were talking about, for example, in the recent time was this BPF observability for Kubernetes, for Linux kernel in general. And one of the like a selling point there is that like it's super flexible and configurable. So you can extract pretty much low-level stuff literally out of kernel, essentially anything you want. So I wonder if similar model could be applied actually for Postgres world, when essentially, as Steven said, you can essentially extract everything that you want in the similar way that you have described directly from under the hood of Postgres without actually exposing it via SQL interface. Does it even make sense?
So in Postgres, there's a convenient thing that was framing the way I was thinking about it, which is these stats that are gathered in shared memory and on disk. Most of the stuff in PG stats, blah blah blah, are all being gathered on this data structure on disk through shared memory, and they're outside of the usual transaction and system. And so it's very tempting to assume that everything we want is in there. There's also some things in shared memory so if you look at like PG stat activity and PG stat replication, PG stat replication status, PG stat replication slots, things like that. Those are mostly just exporting data structures from shared memory. I don't know. I mean, I don't know how to do the equivalent of what the kernel's done. I mean, you could do it with eBPF yourself. eBPF can load symbol tables and understands pointers and can track things down. But like, you have to understand all these data structures in Postgres, and they change all the time. I mean, the idea.
Well, I didn't mean it literally, of course. I mean more like figuratively, if this approach could be feasible, because it will solve a lot of problems. Even for example, the case that I have mentioned before, where there are some metrics that are just not feasible to export for every case, but for certain particular edge cases, it makes perfect sense, because it's like for example, for sub-transactions, like sub-transaction overflow, everything goes down, everything goes south, and for some certain cases, you would like to monitor it. So this kind of configurable stuff would be able to solve it, because you would be able just to create some particular, not necessarily a query, you would be able to create something that will extract only this part without significant overhead for everyone else. So again, I'm not sure if it makes sense from the technical point of view, like in the Postgres world, but at least that sounds pretty much ideal just from the high level view.
I have to say that I think we ought to implement some kind of monitoring for sub-transactions anyway. Like, we should just have that. I mean, I think the idea that stupid overhead is a little bit extra, personally. But that's, you know.
I'm sure there are things that would be a lot of overhead, but like, it seems to me like the way to solve that is to gather, like, to have the code to gather that stuff, and then maybe have a switch to turn it off if it's too much data. I mean, the reason the kernel thing, eBPF, is so powerful is not that it lets you gather stuff that would otherwise be overhead. It's that it lets you gather stuff that nobody thought of gathering before, which is,
well, not necessarily,
hard.
because there are some metrics that are literally available for monitoring only because you can collect them from the kernel, but it's mostly because of the, context switch and all this stuff. So I'm not sure if it's actually relevant in this case. But yeah, definitely flexibility is like one of the essentially killer points here, right?
On a related note, one of the complaints I have with the Postgres stats is that they don't have very much OS data in them. So like we do things like how many blocks you've read, but that's how many times Postgres issued read. It's not how many blocks the file, like the kernel actually read. And so like there's the reason for that is there aren't really very portable. There are old portable interfaces and there are modern non-portable interfaces, and like they both have downsides. So Postgres does use getar usage, but only in some old code that is not well integrated with the rest of the stats system. So one of the things on my to-do list is to get the stats from getar usage and make them available through the same stats tables. So like PGStat all tables would have a column for IO. Well, actually that you wouldn't have that from getar usage actually, but PGStat statements could have getar usage data for your query, for example. But getar usage is not very, it's not super useful in a modern world. It has very old-fashioned way of looking at those measurements, and there's much better measurements available from like eBPF or the equivalent, but those aren't portable. So I was thinking about this, and my thinking was to even getar usage is not portable to Windows, and that's what actually undermined my patch the last time I tried this. We have a wrapper for getar usage in the ports directory that tries to make implemented on Windows, but it doesn't do it exactly, and it was driving me nuts. So my thinking was that it would be good if there was a way to get arbitrary kernel metrics using eBPF, and there was some extensibility in the Postgres stats so that you could, in an extension, use eBPF to fill in more metrics. I mean, we can't, I don't think it would fly to make Postgres use eBPF directly and depend on it directly, but if we had extensibility so that you could load an extension that used an operating system specific thing like eBPF to fill in more stats, I think that would be the way to get more OS specific data. So you could do things like how much bandwidth occurred during this, how much IO did this query generate on the network, which would be perhaps super useful if you're using foreign data wrappers, for example. If you have latency. Yeah.
So
Go ahead.
You're talking about some sort of computed columns for each system view that will be generated at runtime, and depending on what extensions you've loaded. Something like that to make those views extensible.
I was actually thinking about it the other way around, that like when we generate stats to send to the stats well, I mean, there's different stats views. Some of them are just generated at runtime, like PGStat activity or something. But I was thinking about more like things like PGs. Now, sorry. Now I'm thinking out loud. I guess I was thinking more of PGStat statements, that there would be like at least what I was thinking I can only now express clearly for PGStat statements. That when it like at the beginning of the query, when it snapshots the timestamp and how much IO, like the some counters are at, it would also get, like the extension could snapshot like whatever kernel metrics it wants, and at the end of the query it could add like there would be some additional columns where it could add some data that would get stored in PGStat statements as data structures. So when you actually go query it, the data would already be there. It would be stored along with but I guess, I don't know, maybe that's sort of equivalent to what you're saying. I guess I would be imagining that this common, like in order to do it the way you were saying, the extension would have like a hash table of key and the value and would add it at runtime. But that seems like extra duplicated effort to me. So then, like, for example, I could have a simple extension that just did get our usage at the beginning and end of every query and added a whole bunch of columns to PGStat statements with the get our usage columns. I haven't thought too much about like how to add I need to read Andres's changes to the stat system because they're quite different from the old system. So I don't know how easy it would be to make them extensible in that way. But then, like, like this is like in I'm going to say something that I'm not sure 100% believe. The nice thing about this maybe is that if an extension added extra columns to PGStat statements or PGStat all tables, those would immediately show up in the metrics that were exported through the system. Like the system metrics would be coming from shared memory and they would just export whatever columns were there. So they would show up in Prometheus and Grafana. So if you loaded a contrib module or an extension off of GitHub, the same extension everyone else is using, it could come with, oh, and here's a dashboard using those metrics. You wouldn't have to plumb the whole system by adding custom queries to get these extra columns and change the queries in the agent or add custom queries to get them, and then make sure that you match the labels that the dashboard is expecting. And you could the extension could say here's a link to a dashboard and here's like some standard alerts that you can load, and you wouldn't have to worry about the whole chain of things in between to get those metrics and to show up in your dashboard.
The trouble with with the extra columns is what about existing applications which, you know, maybe they're not very well written, but they have an assumption about exactly how many columns and types of columns there are in, say, PGStat activity. And suddenly you see, instead of 15 columns in that application, you get 20 columns because an extension was loaded.
Mm-hmm.
So that kind of a issue is still there.
Yeah.
I just want to put a time check out there. We have about 10 minutes left, or 8 minutes, I guess, or so. And then we're going to have another break with the last session that'll be starting at 45 after the hour. So I just want to put that out there.
I should have asked this at the beginning. Did we get a volunteer to take notes?
I've been taking. I have lots of notes.
Excellent.
Okay.
Excellent. I feel
Do I get it right that essentially all the nodes are saying that everything is bad and there is no bright future?
Well, the bright future, I mean, I know what I want to achieve, or at least some of it, which is that, like, you start up Postgres and you turn on standard Postgres dashboard and it just works, and the all the plumbing in between you no longer have to worry about. I don't know that the problem that Grant was getting at about the sheer cardinality being an insurmountable problem is I mean, we have a lot of per object metrics, and that doesn't scale for people who have many databases. That's the main thing that worries me.
May I ask, you've mentioned many times, so apparently there is some ongoing activity or some ongoing project of yours. What exactly is that? Like, I'm not entirely sure that I'm aware about this. Or patch maybe, or like you're working on something apparently, right?
So I think I referred to an old patch of mine with GetR usage. That's from years ago. And what it actually did was added GetR usage calls to explain. So at the beginning and end of every node, it used GetR usage. So where right now we have total time spent in a node and total buffers read and written actually. I added blocks read and written, and there's a number of other metrics in GetR usage, page faults, and a few other things. Well, then there's system time and user time, which is very interesting for explain, because right now we just have basically user time. So that that's actually what I mean. That's kind of a side point from what I was. It was an example, let's say, of like the kind of additional metrics that I might want to, that I think we should be able to turn on easily. Like a module should be able to add something like GetR usage calls and store those values in all the same places that we currently store timestamps, basically, like for calculating time spent in various things. It would, so like PG stat statement could also do GetR usage at the beginning and end. I said PG stat all tables, but I'm actually not clear offhand how that would work. But certainly, I mean, in the abstract, it could work. Like you could call GetR usage at the beginning and end of every IO on a table. It would be very expensive, but like that same logic, that same like pattern would make a lot more sense if it was just getting a kernel perf counter at the beginning and end of every IO on the table. So you'd know how many, say, physical IOs had happened while you were trying to read from the table. Which is basically what GetR usage is trying to give you, but it's more expensive. But that's like just an example. What the patch, like the project that this is part of, is like I want to get native Prometheus support out of Postgres in a standard, consistent format that anyone deploying dashboards and alerts and monitoring can rely on having standard set of metrics. And I guess part of solving that means if you want to add more metrics, there would that needs to happen in a consistent way as well, so that an extension that adds more metrics can also say, here's a dashboard, and it'll just work. Sorry, I'm rambling now.
No, it makes perfect sense for me.
Thank you.
Okay, so we're down to the last couple of minutes. Does anybody have anything, any final comments on this? I'm getting tired of writing, so.
Yeah, I have a
Obaida?
Obaida. Yeah, I have a question for you, Greg. So one of the things I kind of sometimes find useful is per backend overall memory usage, and it's kind of like at least looking at from engine's perspective, right? I mean, from Postgres, right? I mean, you could essentially, without going through all the memory context tree and stuff, understand, hey, how much memory this query is using. Sometimes there is statistics that you can collect about database, but at the same time, there might be information that are useful at the per query level. Now, sometimes you just want to really quickly know what's going on without going over all the context, right? For example, I could just want to say, hey, what is my what backend is using the most amount of memory, and so on, right? And then probably use PG cancel backend just so that you can keep the system up and running. And sometimes, I think we made an improvement in Postgres 13. Yeah, I guess hash batch context that there was some memory. It was taking a lot of memory, and then I guess the speed was really large in some cases. So Postgres 13 has made that improvement. So I guess my point is, having more data about some of these backends that you can quickly get helps you even to see, okay, I want to build a dashboard on how my processes are taking memory and sort of feed into some other metrics. I kind of wanted to understand, what's your thoughts on getting some high level, memory metrics, even from Postgres' perspective, probably, provide if we don't want to change stat activity or something as a new column, we could probably get a new function to or provide that.
So I just want to make a I have a discussion ongoing on the hackers list, and that discussion is limiting memory allocation. And I encourage you to go read that thread and comment on it with what you want, because I agree with you entirely about wanting to have that. And I also want to make it so that that's something that we can control and basically, dictate that, user backends are only allowed to allocate up to X amount of space or whatever, either individually or in aggregate. So like, if that's something you're interested in, I encourage you to go jump on that thread just more generally. Certainly one of the ideas of that is adding to like proc array, a how much memory is this backend currently got allocated through memory contexts, and then dealing with that. But there's likely to be some amount of pushback on that. So
I mean, I think
more people they like it would be cool.
Yeah. Let me get more into this, but I think probably not proc array, because there's locks and stuff. Maybe you would want people are like, hey, no, I already do a lock. Yeah, maybe something no lock. I was doing some testing with Atomic, but then again, somebody would be, hey, there's a lot of Atomic updates you're doing in ASAT. That might be expensive, right? But
I know Ronan was also doing some experiments with the eBPF and glibc trace points that are there, so that you can do things like look at how often malloc, like how often our palloc calls were actually doing malloc, so that because the problem, if you just watch palloc, you depend, like some queries will palloc a small amount of data for each row, but it's always getting discarded, so it's not actually using a lot of memory. So you need to either see like what's actually causing the memory usage to grow. So he was trying to get some data from glibc, or anyways, he was trying lots of different things. It's it's a bit of a complicated thing to get a handle on. If Postgres was tracking it itself, then it would be easier. But there would be overhead.
I just want to point out, I mean, we are over time now.
Okay.
So we should go ahead and let people have an opportunity to take a break, go, make coffee, do whatever is needed. The next session in this will be improving indexing performance, and that'll be starting at 3/4 or 45 minutes, past the hour. So thank you, Greg, for leading this. It's been an interesting talk. I have updated I've updated the notes. If anybody has any issue with it, feel free to go in and modify the notes or comment on them, but hopefully they're pretty comprehensive. So thank you, everybody.